Let's write the balanced equation for the complete combustion of benzene. We're given the formula C6H6. Let's put that on the reactant side. That's the fuel that's going to burn. In a combustion reaction, we need oxygen as a reactant. And in a complete combustion, we're going to get carbon dioxide and water as products. You're also going to get energy in the form of heat and light. Now, in our last video, we took a look at a shortcut on how to quickly balance complete combustions of hydrocarbons, which we have here. This one's a little bit different. In that video, we said the coefficient in front of carbon dioxide should match the subscript of the carbon in the hydrocarbon. But that's not going to be the case in this example. And the reason is the subscript next to the H has to be multiple of 4. I'll explain why later. So I knew we need to double the coefficient in front of the hydrocarbon. And now we can fill in the rest. Since carbon only appears in the molecule of carbon dioxide and the hydrocarbon, then the coefficient in front of the carbon dioxide has to match however many carbons we have in the hydrocarbon, which is 12. And the coefficient in front of water has to match half the number of hydrogens in the fuel, in the hydrocarbon. That's because H only appears in those two compounds. So there's 12 hydrogens on the reactant side in the hydrocarbon. So we need a 6 in front of the water to get us 12. Now finally, the coefficient in front of the oxygen molecule is going to equal the number of carbon atoms in the hydrocarbon, which is 12, plus 1/4 of the hydrogen atoms in the hydrocarbon, which is 3. So it's going to be 15. All right, and the reason is that oxygen comes from a combination of the oxygen and the carbon dioxide, which is tied 1-to-1 with the carbon in the hydrocarbon, and half of the hydrogens in the hydrocarbon, but it's only half of that, so it's a 1/4. I don't know if you followed all that, but in any case, there's your balance equation. I'm going to do this over just the regular, longer way. So if you didn't follow this, you can still get the same answer. So I rewrote the equation so I could show you the longer version of balancing equations. I separate the reactants from the products. On the reactants, I've got 6 carbons, I've got 6 hydrogens, and I've got 2 oxygens. On the product side, I have 1 carbon, I have 2 hydrogens, and I have the oxygens contributing from 2 different sources. So 2 from the carbon dioxide and 1 from the water molecule. So you generally want to balance the hydrogens first and do the oxygens last. We need to multiply the hydrogens on the product side by 3. So that multiplier goes as the coefficient in front of where you see the hydrogen, or in front of the compound where you see the hydrogen. We also need to update and multiply that coefficient to every other element in that compound. The reason I did hydrogen first is because I know right away whether it's going to work out or not. The oxygens on the reactant side can only be even numbers or multiples of 2. So without wasting too much time, I need to rebalance the H's. I'm just going to double what I tried. So instead of 3, I'm going to do 6. That way I get an even number of oxygens on the product side. The reactant can only be even numbers. All right, so that'll give me 12, and that'll give me 6 oxygens from the water molecule. So going over to the reactant side, let's balance the hydrogen by putting a 2 in front of the hydrocarbon. So I got 12 hydrogens and 12 carbons. Now let's balance the carbon dioxide by putting a 12 in front of the carbon dioxide, and also update that oxygen is 24. So I have 30 oxygens total on the product side, and I can balance that by putting a 15 as the coefficient of oxygen. So to get the same answer, it took a little longer, and there's your balance equation for the complete combustion of benzene.